My name is Jeremy Lickness. I am the product manager for the data experience with .NET. And when I think about the data experience, I cover a lot of mileage. Obviously, data pervades everything that we do. So I think about things like APIs. Is it a REST API? Is it a GraphQL API? Is it gRPC? And what is our support like for that? I think about things like the databases developers connect to. We've got Azure SQL, we've got Cosmos DB. And of course, there's other databases like MongoDB or RavenDB that people are using day to day. I think about the products that I work with. So I'm very happy to be working with the Entity Framework core team. That's what we're going to be talking about today. And I also work with the team that brings Apache Spark to .NET, the .NET for Apache Spark team, which is a really fun product that I use quite a bit. And then finally, I think about platforms. So whether it's Blazor, which is blazing the way for the web, or if it's something like the Maui experience, which we're going to talk about today. And I often ask myself the question, why do I love .NET so much? Because I have a passionate love for .NET, and I have since it was in beta. And if I'm going to be honest with myself, the answer is tied up in the reason why I'm excited about .NET Maui. The first thing is I've worked with a ton of languages, and I do a lot of web development, so I'm a huge fan of JavaScript and TypeScript, but C# has always been my favorite language. And I love the fact that it's plugged into a runtime that lets me do the things that I want to do on the platforms that I want to do it with. And with the latest releases, it's literally any platform that we want to code for, we can use those languages and runtimes that we're excited about. And finally, I can focus on the solution. I'll give you an example. I have a hobby of astrophotography, so I was happy when James said that I was his favorite in the galaxy because I was just imaging a galaxy the other night. And when I write tools, I want those tools to be accessible to everyone. And something like Maui allows me to focus on what I know, which is writing the solution in the tools, and then the platform can handle the implementation details. So I don't have to be an Android expert, or I don't have to be a Mac expert to make that happen. This statement really resonated with me. This is off Matt Sokoup's blog post about .NET Maui. And it's that it gives you a first-class cross-platform UI stack targeting Android, iOS, macOS, and Windows. And as I was thinking about that, though, I thought, you know, what about data? What is that data experience like? And so I set out to do a proof of concept. And what I'm going to use for this proof of concept is a publicly available food database. In fact, I'm going to click into this right now so you can see this is a place that you can go. This database has been around for over a decade. I know I've used demos with it back as far as and I had to sneak this in because it's .NET Conf Silverlight days. But I was using this database. It's been modernized. You can now get it in a JSON format. And it's a perfect way to build a demo application because it's got more than one table. So it's not just a simple Hello World app, but it's small enough that you can sort of wrap your arms around it. This is a very simplified view of the database. We have this concept of foods. Foods have nutrients. They have portion sizes. And what I wanted to do was build something that let me search for foods and find out nutrition facts, but also look for what I call power foods, which is being able to say, I need a certain nutrient. Maybe it's calcium or protein. How do I get that nutrient? And I think you'll see from this example where the power of Entity Framework Core really comes from. So let's take a peep at the application, and then we'll look behind the scenes on how it's built. I'm going to pop over here where I've got my Android emulator running. And what I'm going to do is just type in a simple search. So baked products, let's go for bread. Here we have a couple results, and we click in and we get the nutrition facts. So pretty straightforward example there. The fact that this is Maui means that I can also deploy this to Windows. So here's my Windows version of the app running. And I'm going to go into the Power Foods. We'll come back out. There we go. The UI is now looking golden. But let's say protein is what I'm interested in. I'll click on protein. And I get the list of foods ranked by which food has the most protein in it. And then I can drill into that and again get the nutrition facts. So that's the simple application. Let's talk about what powers that experience. So EF Core, like Maui, gives you a first-class cross-platform data access API. So instead of a UI platform, it's a data access platform. And we target everything from SQL Server to Azure Cosmos DB to MySQL to Postgres to SQLite. There's actually even more providers because the way our product is built is it is extensible. So companies can extend and provide what we call a provider model to provide an implementation. So what do you get for using Entity Framework Core? Why would you want to include that over, say, for example, just 8.0.NET? It's domain model friendly, and I'll show you what that means in a minute because it really plays well with your existing C# objects. It allows for a fluent configuration. It has a swappable provider model. I already talked about that. But the other thing we have is what we call escape hatches. I love the escape hatches because a lot of times people think it's an either-or proposition. Either I go with this technology or I go with that one. For example, there is a product a lot of people feel competes with Entity Framework called Dapr that translates database commands and does a really good job of taking raw SQL and turning that into C# objects. We don't consider that to be an either-or proposition. There are parts of your application that can benefit from running that and parts that can benefit from Entity Framework. But our philosophy is everything we implement, we allow you to drop down to the database level and really get to the details and get done what you need to get done. Link should really be a flashing sign, blinking, expand out. I could have done some animations in the PowerPoint because this is by far the most powerful tool I believe C# developers have to work with data, is that ability to use the C# language or the other languages that are supported by .NET to describe a request from the database. And I'm going to show you just how powerful that is with one example in a second. The last thing I want to touch on is performance because there is a misconception that object relational mappers automatically mean low performance. And the reality is we are part of the Tech Empower benchmark, which is an industry standard benchmark. And EF Core, you can look up the scores really well. The team has put a lot of effort into optimizing what it does. And in some cases, believe it or not, it may actually outperform handwritten code because of the knowledge that the team has behind how they optimize it. If you search for EF Core performance, you will find some blog posts that talk about the performance improvements we've been putting into EF7. And EF7 will actually improve the update pipeline in some cases as much as 4 times over previous versions. So you want to check that out. Now, when we're dealing with mobile apps, it doesn't really make sense to connect directly to SQL Server or Azure Cosmos DB, for example. In some cases, because you simply don't have access to those ports and protocols, a lot of times the device isn't on the secured network, and it's just not a good idea to have credentialed access from that device directly to the database. So in those cases, you're typically going through an API, something like GraphQL, something like a REST endpoint, and that's how you get your access. But when you're dealing with data locally, whether it's offline or data that's going to synchronize with an online database, this is where something like SQLite comes into play. It's a very powerful tool because it's standalone. It's what we call in process, so it just runs as part of your application. There's no need to set up a server. It's ACID compliant, so you know that when you save something and you get that response back that it's saved, that's actually committed. And what's nice about it for the mobile experience is it's really just a single file that you deploy. So you can prepare a database and preload what you need in that database and ship it as part of your application. So it checks a lot of boxes. The question is, SQLite comes with 8.0.NET drivers, so you could program that way against it. Why would you not do that as opposed to use, for example, EF Core? So let's pop over to a little demo I put together to demonstrate just how this works. Now this demo is a console app. It's using the food database. And what I can do is just pass it some parameters. I'm passing it a category to search for and a food item to search for. So here I'm looking for baked goods as a category and bread is the search. So I'm going to hit enter and it's going to run it twice, one with SQLite and one with EF Core. And you can see we got the exact same response back. probably one of the more boring demos you've seen, but the magic is not in the output, it's what's behind the scenes. Let's take a look at the code. I'm going to pop into Visual Studio Code. My main program basically does the same thing twice. First, it calls the SQLite example, tells it to find the category in the food, and then shows it. And then we do the same thing with the EF Core example. So it's side-by-side code, and this show takes a food category, iterates through, and lists the items. So very normalized in that sense. Now let's open the SQLite example. So if I'm going to use 8.0.NET, here are the steps I need to take. I need to create a connection, pass it a connection string. There's a connection string builder I can use to help out with that. Now I've simplified this demo code because if anything goes wrong, we're hosed. The application is going to crash because I'm not using a try-catch block. I'm not parsing the errors. So there's a lot of handling that goes into this that I'm not even showing so I can keep this simple. But let's assume everything goes fine and it opens that connection. Next, we're going to send it a command. And here's every developer's favorite way to code is to throw strings around in code. So we have a nice big string that's a query. And on top of that, most developers I've met are familiar with SQL. Some may not be, but you have to know SQL, and you have to know how tables relate to each other, how they join to each other. And what's even more important is even similar databases have different dialects. So SQLite, looking at a string comparison, is slightly different than SQL Server. And you have to know that nuance. So let's assume we know all that. We've got that built into our string. Now, because we're security-minded, we don't want parameter-based, or I'm sorry, SQL injection attacks, right? We don't want someone to stuff bad data into our string and cause an issue. So we're going to protect that by using parameters. So I'm setting up a food category parameter and a food parameter. Now I can actually execute the command and get a reader. While I'm reading it, I get these nice index tables. So I've got an index of the column name, or I could even do 0, 1, 2, 3 if I know the order of the columns. And I'm doing something very unsafe here. I'm trusting the database to give me the right types back, and I'm casting these from a long to an int or a string, and then populating my classes with them. So I'm manually doing that. If this was a production application, I'd have to wrap each one of these in additional logic just to make sure that the conversion was going correctly. And then we get the result. So that's the 8.0.NET experience. Let's take a look at the EF Core experience. So in Entity Framework Core, this is my code. I create what's called a context. That's my gateway to the database. And then I tell it I want food categories. Please include, because there's a lot of properties that hang off of it, let's just include the foods off the food categories. Oh, and by the way, I want the food with the matching description. I want you to order it by the description, so they come in a order. And then I want you to also give me just the very first category that matches my search. So this is a very fluent, straightforward way to do that. And regardless of whether I'm talking to SQLite, SQL Server, Cosmos DB, or any of the other databases we support, this will be translated into the right dialect for that database. I don't have to worry about it. This is the only other setup I have. I have to create something called a DB context, which is my gateway to the database. And I'm basically passing it a connection string, and then I'm giving it this set of food categories because the foods and the categories are the things I want. Now, there's other items in the database, but a context is really that. It's just a context. So I'm creating a context around just the content that I'm interested in. Let's go ahead and uncomment this one line, this log2 line. So this is a very simple configuration block. It's just saying send informational logging to the command line. And I'm going to come back and I'm going to rerun this query. And of course, I will want to save before I rerun if I'm doing it from the command line. If I F5 from Visual Studio Code takes care of it for me. So now we've got some of the logging that comes out. It was a very simple way to turn on logging. You can see that it's telling me using provider, SQLite with options. And here you can see the database command, which looks very different than the one I came up with on my own. But again, these are commands that the team has worked for literally years and years to know how to optimize and provide the best possible experience. So the next thing we're going to do is pop over into Visual Studio, and we're going to take a look at that food application proof of concept that I built. So if you recall, it had really two main features. There was a feature to search for a food and get the food information, and then there was the Power Foods feature, which gave me the foods ranked by nutrient, so I could look at calcium and protein and everything else. So in this application, I mentioned that normally you would pre-populate your database and ship that with your application. I wanted to show some of the power of EF Core in this application. So this has the JSON embedded inside of it. And I've got the food data here. Let's open that up. So I've got this massive JSON document that's embedded into my application. And I put the code to parse that out so that we can save it to the database. Here's the key though. Whatever parsing or setup logic or whatever happens, that's independent of using EF Core or ADO.NET. At the end of it all, I'm getting a list of foods. Now remember, those foods reference nutrients. Those nutrients reference measurement units. So you've got portion sizes, etc. So there's about, I think, 6 or 7 tables involved with this. And we've got things like what we call cycles. So a category contains a list of foods, but a food references back to a category. And multiple nutrients might reference the same measure unit. So in this simple list of foods, there's a lot of data to unroll. I'm going to expand this code and show you what it takes the first time you run this application to set up the database, to actually build out the schema and save all of the data into the database. So here we go. I basically tell it that I'm adding some new foods, and I tell it to save changes. That is it. And the result of that is something that still blows my mind when I think of the complexity of what it comes up with. Let's go into Visual Studio Code because I've got this SQLite browser, and I'm going to open up, let's close these out. Going to open up my database. So those 4 lines of code created all of these tables. We've got our food categories, and notice they're not duplicated, so they're a unique list of food categories. We've got our list of nutrients with data points, medians, etc. We've got portion sizes. We've got our actual foods. We've got input foods. Now, when this reports that it has 180 foods, there's really more like 600 or 1,000 that you can search on, but multiple foods map to kind of the same generic portion size. So there's 15 different ways you can enjoy hummus, and it has one entry that has the information about hummus in it, if you can enjoy hummus. It's not for everyone. And then we've got our measurement units, we've got our nutrient conversion values, and our nutrients. So a lot packed into a single call that's building out that database. So that's just the setup. But what I wanted to show is you can have a very complex object graph, and the same thing can happen for update that happened for this insert to seed the database. You can change one property that's out on a node on your graph, and EF Core will walk through that whole graph, figure out what changed, and write the SQL just to deal with the change. And you don't have to worry about that yourself. Let's walk over to the search view model. And this is the search functionality. So there's a lot going on in this view model. We have a debounce, so as they're typing, we're not like constantly slamming the database and doing this and that and the other. But at the end of the day, we end up with a property that has the search text that you're searching for. Let's look at a few things in this one. We'll expand the search out. So this is the main code for the search. And again, this is using Language Integrated Query, or LINQ. And the concept is the same concept as before. Basically, a very fluent way of describing, I want to say where the food category matches, and the search data field contains search, and I'm going to order it by description. Very straightforward. Then I iterate through the results. I add them to my observable collection. I raise some property change notifications, because who doesn't enjoy doing that for view models? And the application updates and shows what I need to show. The Power Foods is a little more complex. So let's pop over there and see how we tackle this one. So with the Power Foods, what I'm saying is I've got this concept of a nutrient that's buried inside the food, but nutrients reused across different food items. So I may have food item X that has 5 protein and food item Y that has 10 protein. So what I need to do is I need to go from the food, that's this, to the nutrient, which the food nutrient is the amount, and then the actual nutrient entry itself. And that's how I get down to the nutrient for the food. I'm using select mini, which allows me to take child records and flatten it out. So instead of a top level food item A and a top level food item B, we get A, A1, A, A2, A, A3, where A1, A2, A3 is like the second level. So we're basically taking those nutrients and creating a row per nutrient. So now that we've got that, and this is a projection, so this is a different way of looking at the data, then we're going to filter it. So we're filtering it to the nutrient we're interested in, ordering it by the amount descending. I only care about the top 10. I'm not going to scroll through everything, so I'm going to take 10. And then I'm doing another what's called projection, which is basically out of all the information in the database, I only need 4 elements. I need the ID, the description, the amount, and the unit. So I'm projecting that into my own class, and that's what I'm using in the UI to display it. And I wanted to show this for 2 reasons. First, to show that EF Core supports those projections so that you can get the data into the format you need. But second, I want to make a note on what goes on behind the scenes. When I project the data, it's not pulling back the entire database and then cherry picking the columns that it's interested in. When I do a projection like this, it is actually mapping that projection to the database dialect. So you get a select statement that literally selects ID, description, amount, unit. In fact, if we pop back over to our example here, you can see down here, actually I didn't project this one, but oh, right here. So ID, description, and food category ID. So that projection is being sent to the database and letting the database do what it's good at, which is filtering columns and sorting, etc., and not leaving that workload for an afterthought or bringing back too much. So it really streamlines the process. And then you pair that with a powerful API like, for example, GraphQL, and you really get this streamlined ability to grab data all the way end to end in your pipeline. So let me just double check. I get the Power Foods, I add them to my collection, and I show them, and that is that. So having shown that, I've got a very, very special next slide. Very exciting, and that's a thank you for joining. But I wanted to give you a very easy link to remember. That's aka.ms/efdocs. That is your gateway into Entity Framework Core. It contains all of the examples, documentation by provider, tells you how to get started. We're working on experiences by platform, so take a look for all of those. Thank you so much for your time. I am the product manager for data, so if you have a bit of feedback, want to have a conversation, or would just like to generally talk data, feel free to reach out to me.